Very good morning to all respected participants, students, and faculty members of various engineering colleges. I warmly welcome you to Day 12 workshop on drone applications in disaster management. Let us have some pre-introduction about the topic drone application in disaster management. So generally speaking, natural and man-made disaster continue to pose significant threats to human lives, infrastructure, and the environment. Due to the recent advancement in unmanned aerial vehicle technology, commonly known as drones, have transformed the disaster management practices by providing rapid, accurate, and real-time information during emergencies. In today's workshop, we will explore how drones are being utilized across various phases of disaster management, including preparedness, response, recovery, and mitigation. We will also examine some practical case studies and future development in this rapidly evolving field. Let us go through the workshop objectives. The primary objective of this workshop is to understand the growing role of drone technology in disaster management. Initially, we will discuss the challenges faced during disaster situation and why traditional response methods are often become more insignificant. Second, we will explore various drone platforms, their operational capabilities and the technologies integrated into these systems. Third, we will analyze the real-world application of drones in disaster monitoring, search and rescue, emergency response, and damage assessment. Finally, we will examine emerging trends such as artificial intelligence, autonomous drones, and digital twin technologies that are shaping the future of disaster management. By the end of this session, participants will gain a comprehensive understanding of how drone technology contributes to saving lives and improving the disaster resilience. Followed by the workshop objectives, now we will move on to the topic introduction. Introduction to disaster management. So, disaster management refers to the systematic process of preparing for, responding to, recovering from, and mitigating disasters. In general, disaster management cycle consists of four major phases. The first phase is said to be mitigation, which focuses on reducing risk before disaster occur. Second phase is preparedness, involving planning, training, and resource allocation. Third phase is response, where emergency actions are being taken immediately after a disaster. Fourth phase is recovery, which involves rebuilding infrastructure and restoring the normality situations. Here, modern technologies such as geographic information system, artificial intelligence, IoT devices, and drones have significantly enhanced disaster management capabilities by enabling faster decision making and more effective emergency operations. Why drones are highly used for disaster management? Drones have become an important tool in disaster management due to several unique advantages as follows. One of the most important advantages is rapid deployment. Drones can be launched within minutes and reach the disaster location quickly. Another major benefit is real-time situational awareness. High resolution aerial images enables the emergency team to understand the severity and extent of damage. Drones can safely ac- access to hazardous areas such as flooded areas, collapsed buildings, wildfire zones, and chemical spill sites where human access may be more dangerous in nature. Compared to helicopters and manned aircraft, drones provide a cost effective solution for surveillance, monitoring, and data collection. These capabilities make drones highly valuable for emergency responders and decision makers. So here we will discuss the different types of drones employed for disaster management. Multi-rotor drones are the most commonly and are highly suitable for aerial photography, inspection and search operations due to their ability to hover and maneuver precisely. Fixed wing drones offer long flight durations and greater coverage areas, making them ideal for large scale mapping and monitoring missions. Hybrid drones combine the advantages of both multi rotor and fixed wing platforms, offering both hovering capability and extended range. Autonomous drones equipped with AI interface can independently perform the rescue missions, avoiding obstacles and collect the data with minimal human intervention. From the above, it is mainly concerned with how far we are selecting the most appropriate drone depending on the mission objectives, terrain conditions, flight duration requirements, and payload capabilities. Now let us see the applications of drone used for disaster management. Before disaster case, drone play a significant role even before disaster occurs. One important application is risk mapping. High resolution aerial surveys help to identify the hazardous areas subjected to flood, landslides, and coastal erosion. Drones support flood prediction by collecting topographical and hydrological data that can be integrated into predictive models. Infrastructure inspections of bridges, dams, power lines, and communication towers helps to identify the structural weakness before they become critical during disasters. Drones also contribute to early warning systems by continuously monitoring environmental conditions and transmitting data to disaster management authorities. Such proactive measures significantly reduce disaster risk and improve preparedness. Applications of drone during disaster case. Disaster response phase is where drones demonstrate their greatest value. During search and rescue operations, drone can rapidly scan affected areas and locate survivors trapped under debris or stranded in remote locations. Thermal imaging cameras enable drones to detect body heat even during nighttime operations or in low visibility environments. Victim localization becomes more efficient as drones provide accurate GPS coordinates to rescue teams. Drones can also function as temporary communication relays when conventional communication networks fail due to disaster impacts. These capabilities help emergency responders to save lives while minimizing the risk to rescue personnel. Let us discuss the applications after disaster. After a disaster, rapid assessment of damages is essential for recovery planning. Drones provide detailed aerial images and three-dimensional models of affected areas, enabling the authorities to evaluate structural damages quickly and accurately. The collected data supports infrastructure monitoring, allowing engineers to identify damaged roads, bridges, power systems, and buildings. Insurance companies increasingly use drone generated images to verify the claims and accelerate the compensation processes. Recovery teams can utilize the drone data to prioritize reconstruction efforts and allocate the resources more efficiently. Thus, drones significantly improve the post-disaster recovery operations. Let us see few information about the types of sensors and the payload requirements in drone for disaster management. The effectiveness of drones largely based on the sensor and payload it carries. RGB cameras require high resolution visual images for mapping and inspection purposes. Thermal cameras detect temperature variations and are particularly useful in search and rescue missions, wildfire monitoring, and infrastructure inspection. Lidar technology uses laser pulses to generate highly accurate three-dimensional terrain models even in dense vegetation. Multispectral sensors collect data across multiple wavelengths, helping assess vegetation health, water quality, and environmental conditions. Communication payloads enable drones to function as airborne communication hubs during emergencies. Integration of these advanced sensors greatly enhances situational awareness and operational effectiveness. Let us now see some real life case studies. Let us examine several real world applications of drones in disaster management. During flood events, drones have been deployed to monitor rising water levels, identify the isolated communities, and guide evacuation efforts. Following major earthquakes, drones have been used to inspect damaged buildings, assess infrastructure stability, and locate survivors. In wildfire management, drones equipped with thermal cameras monitor fire spread, identify the hotspot, and support firefighting strategies. During cyclones and hurricanes, drone assist in damage assessment, infrastructure inspection, and recovery planning. These case studies demonstrate how drone technology has become an essential component of modern disaster management systems worldwide. Let us go through the challenges and regulations. Drones face several operational challenges in disaster management. Flight permissions and regulatory compliance remain important considerations, particularly in restricted or sensitive areas. Battery limitations can restrict flight duration and operational range. Weather conditions such as strong winds, heavy rain, and poor visibility may affect drone performance and safety. Data security and privacy concern arise when collecting large volume of aerial images and sensitive information. Addressing these challenges require robust regulations, technological advancement, and proper operator training. So next one is nothing but the future trend of drone technology in disaster management. AI-enabled drones will be capable of automatically identifying the hazards, detecting survivors, and analyzing the disaster impacts in real time. Swarm drone technology will enable multi-rotors to collaborate and cover extensive disaster areas simultaneously. Digital twin technology will create virtual replicas of disaster prone areas, enabling predictive simulations and risk assessments. Autonomous disaster response system will reduce human intervention while increasing operational efficiency and response speed. These innovations will enhance the emergency management and significantly improve disaster resilience worldwide. So, just before the closure of today's workshop, we now conclude the following key takeaways of today's program. So these are the following takeaways as listed here. We explored how drones contribute to all phases of disaster management, starting from preparedness and mitigation to response and recovery. We examined different drone platforms, sensor technologies, practical applications, and real world case studies. We also discussed challenges, regulatory considerations, and emerging technology that will shape the future of disaster response. Drone technology is no longer merely an aerial imaging tool. It has become a strategic asset for saving lives, protecting infrastructure, and enhancing disaster resilience. So, with the above few information, I thank all the member participants for sparing your valuable time in attending today's workshop. So, we will meet in the next subsequent learning session. The topic identified for the next day program, application of drone in entrepreneurship development. So with this few note, once again, I thank all the members. Thank you all.